Hi viewers and welcome to the channel, and today we're going to be looking at the part and part design workbenches. We're going to be looking at the reasons why we have two workbenches, when you would use one over the other, and comparing them and their workflows. We're going to be putting some practical examples together to show you what we'll be using those for and how we can combine them as well. So sometimes we need to combine both the part design and the part workbench into our workflows. I hope this can answer a few questions regarding these workbenches to understand the reasons why those two workbenches exist. If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a coffee site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. So to understand the reasons why we have a part design and a part workbench, we're going to first look at the part design workflow and how it works. Now this is a very contained workflow. If you look at the screen, we've got a simple part in front of us that we created with something that is called a body. So this is the first item that will be created when you create a new model. So we go new, we're in unnamed, we're in the part design, and we look at the tasks. If I create a body, then we've got an option in here. We can start a body and we can create a sketch, and we pick the plane. So straight away we're going to be pushed down a workflow. So we're going to be creating a body, then a sketch, and then what we do is add material to this with additive or subtractive. So yellow is additive and red, you can see the yellow tools here. These are additive, these are subtractive. So we're adding and removing material to create our object. And this is in line with common day CAD practices. And you can see straight away with the task, it's forcing us down a workflow. So if we look at the part design compared to the part, what's happening is we're going to be in a contained workflow in the part design, which allows us to create our models without breaking out to other workbenches. We'll break out to the sketcher, but that's basically really the only one that we're going to be using in there. There are other workflows that interact with the part design, but not many. But I'm just going to add a subtractive action to this, or subtractive feature, and hit OK. Through these, you can see we've got this tree view, and inside the body, we have a number of actions here. These are called actions. The very last action will have a green icon with a white arrow in. This is known as the tip. This is the last action that's been created on the object. Any following actions will follow on from the tip. We can go back and modify sketches of other parts. So for instance, this one, I can create this at bigger size, and that will take effect down the chain. But we have to be careful, because underlying sketches, when modified, may interfere with future features that we place upon here. So what we're actually doing is going back in time and modifying these features. So these are future features here. When we modify a previous feature, then we have to be mindful of the next features in the queue. Let's go back to this item here and look at the body and see how this is built. Because this is parametric, we can see the start of the model. So anything like Blender, we're not using a parametric way of creating our models. We're creating them from meshes, and we're modifying that mesh, changing the underlying vertices and faces, and molding that mesh like a piece of clay. With parametric modeling, what we're doing is modeling it like a piece of clay, but if you think in sections. So this will be a slab of clay, and then we add another slab on top of that, and then we add another shaped clay on top of that, and we carry on. We'll remove some pockets, but we can keep them aside because we may want to put those pockets back in and change, let's say, the diameter of these pockets for a smaller diameter. So if you think of it in that way, that you're actually creating slabs of clay and adding or removing them from the object, then you wouldn't go wrong. Remember, we've got the yellow and the red. So yellow additive, red subtractive. And this is, as we move through, we can see the actions or the features that have been results of those actions that create the model, going all the way through. And these, as we go down, can be modified. Example of this breaking would if I come into this pad and this sketch, and if I go crazy with this and say that's set it to 50 and hit OK and hit close, you'll see a red mark come up along this model down here. This hasn't actually taken effect, but if we move back to the pad and bring back the sketch, you can see it has actually taken effect on there, and we can move through the model and we can see where it starts to break. So that pocket there, this pocket, you can see the pocket has appeared at the top here. The fillet, now look at where the fillet is. Because we moved the underlying geometry and made it wider, we've got this feature here. Now this chamfer cannot be applied to this because we've now got two edges when before we had one. So this chamfer will be broken. You can see what's happened there. And though it's taken effect, go back to that fillet, we can see half the geometry is missing and it's gone back to our original geometry. So we've got a problem in here. We can come in to this chamfer and see if we can fix it by looking up and looking at the base fillet edge 54. If we look at the edges, it was one of these edges that it was applied to. We can see those edges no longer exist because we got two edges in here than what we had before. So just hit Ctrl Z to undo and Ctrl R a couple of times to get back to that. So Ctrl R will refresh the model and recalculate because we'll have these ticks. So you can see that this body here, it's got a tick by it. So hit Ctrl R and that's gone now. So we've gone back to our original fillet there. So our sketch, we look at it, it's at 25. And let's hit close. So we've got no errors and we can bring back that chamfer. So you can see the fillet's made up of one edge there, which has been chamfered. So this was the breaking change that caused that by editing the underlying sketch. So we have to be mindful of how the geometry is created as we go along. If we get an error like this, then we just go back through our chain. So as said, the last item in here is the tip. And you can see how contained this workflow is. Everything in there is all that you need to create your models for feature-based modeling. Some caveats around there is when we start getting into stuff like NURB surfaces, or we want to do something very specialized. FreeCAD, if left with just the part design, it will have the part design and the sketcher and some of the other workbenches such as the tech drawer and the path workbench to create CNC paths, and that's all it will be. The other workbenches such as the part is a Boolean workflow, but it has a number of essential tools that are on top of that. So before going on to the part workbench, that's just recap on what we said. The part design, if it only existed in FreeCAD and none of the other workbenches such as the part, then we would have part design and probably just the sketcher. We would have the other ancillary workbenches such as text drawer and CNC path. It works on a linear workflow and the last action is the tip. Now the part workbench is a much looser workflow and it allows you to go from one workbench to another, flowing through those workflows and creating something a bit more complex. Part design is good for feature-based modeling where we have a well-defined part. In the part workbench, we can be a bit more organic with our modeling. So let's have a look at the part workflow. I've now got the part model on screen and we can see that they're both basically identical. So here's the part design and the part, and what we're going to be looking at is the workflow between these. So in the part workflow at the moment, looking at the workflow, we can see we've got a nested tree view here of all the different features. Our top feature is the fusion. Now, fusion is an action that's created by a boolean together. So we're booleaning two parts together and creating one. Inside that fusion, you can see we've got a fillet and a fillet mirror. So these are individual actions. What I'm going to do is hide the top level fusion and bring back the fillet. And you can see how these are nested in here. Let's bring back the fillet mirror as well. So I'm just clicking on and pressing the spacebar, hitting the top one, and I'm showing the children of the parent. You can see these two have been fusioned together to make this fusion. So what we have is the result of the action with the two parts underneath. If I deleted this one, this will break this out, and now we have the mirror here. But we can't see the actual fillet of what we mirrored. That's actually inside here because that's an action upon here. You might be wondering why they're not separated out underneath, because if I go back, we can see the fusion and we've got two actions underneath. This is to do with the tree view allowing us to create Boolean actions with parent and child actions. So if I go back and delete this fusion again, bring back the fillet, and we can see that inside we have a fillet, here's the parent, here's the child, and then we have more child underneath. We can actually take the parent, control click the child, and create an action against those. So we can create a union, that creates one single fusion, which allows us to refine it to true. And you'll see that these edges will disappear because they're unneeded. So we get our refined model. So let's go back to the tree view and explain what's happening. So we've got the parent action, the topmost, and then nested in we have the other actions. So we can see the fillet there, and inside there is fillet 001, which is the same as this one. So if I showed this fillet, you can see the other fillet is being shown as well. Let's hide that fusion, come back to the fillet, because these two are the same object. This action required these two to be boolean together, and this is why you see it nested, because we have object 1 and object 2 that was selected and boolean together. If I create a new document and create a new part, we can see what happens here. So if I put, say, a cylinder in here and another cylinder and transform these, and then we take these two and boolean them together, this creates the fusion. So inside here you can see the two items that we fusioned together, and then we use a mirror against there of the fusion, and we'll pick a plane, say YZ plane. So we've mirrored that across. We now got the fusion mirror and what we use to actually mirror that across. Because it only required one single object to actually mirror, then we've got one object under here. If I want to bring these together to make one coherent part, I have to control select the parent and its child, so the mirror and the fusion, and we make a boolean or a union of those. We now get this fusion with the refine, which we can set to true. That refines that face down, and inside that you can see the two items that we selected to create that action. And this is the way the part workbench works. So it's Boolean operations, cuts, fusions, intersections or commons of those shapes. So going back to the model, I've expanded the tree out so we can see it's nested deep down to our main building blocks, which are these. So if I hide the fusion and bring back these three, these were our main building blocks. Those were combined together in a Boolean union to create a fusion. So if I hide these now and bring back the fusion, you can see it there. So let's collapse that one. Next comes an extrude, which sits on the bottom there, and that was used with that fusion, so you can see them side by side underneath its parent, the cut, to create the cut. So those two were taken and that creates the cut. Next we have an extrude, which is in line with this cut for this operation here. So the child is this cut and this extrude We come around, we can see that there. And those we use together to create this cut. Notice that if I come in here, we're using sketches. This one, I've used a circle. It's just because I can. There's no reason why I've done that. I've used a circle from the draft workbench. And this is a thing we'll get into later regarding pulling in other items from other workbenches. So the extrude and the cut we used to create another cut between those to create this cut. So you can see that's been removed from there. And then moving up, we've got some finishing actions such as a chamfer. Hide that cut, you can see the chamfer going along there. And then a fillet. Hide the chamfer. You can see the fillet going around here now. And then moving up, we've got the other fillet, which is just rounding off the edges. We then took that fillet, and you can see if we close that, we've got this fillet showing and the bottom fillet because they're both the same object, and we mirrored this here. This one's outside of the parent because this is something, as we said before, this is totally different action that was created. So ignore this one, just look at the parent and look at the fillet within. So we end up creating these two. The ending result is this fusion, which we look underneath. Let's close this one down. It's taking these two, which is the fillet and the mirror. So we took this fillet and this fillet, because this one wouldn't be shown because the action wouldn't have created it yet, because the action hasn't been actually run, and we combine those together to make the mirror, to make this last fusion. And we can hide these. And that's the way the part workbench works. What we'll do now is understand the reasons why we'd use one over the other. So when would we use the part workbench over the part design? Other workbenches can utilize the part workbench in their workflow. For instance, if we come into the curves workbench, then making something in here such as a sweep profile on 2 rails, then this will work hand in hand with the part workbench. So we go to the sketcher and we'll create a number of edges. We can even use something like the draft workbench to create these edges instead of the sketcher. We can use the curves workbench to create some curvature across here. Then we need to create planes to connect these two together. We can only do that from something like the part workbench to create a ruled surface. Then we can swap back to the curves workbench and use that ruled surface against the arcs. To create a point cloud, which allows us to create a nerved surface. We can then take that nerved surface, open the part, and create offsets against that, and fill the offsets. So the part workbench allows you to create and manipulate surfaces, and also allows you to modify those into something that is solid. The part design only allows you to create features that create solids. So the following video shows me going through actually taking that propeller blade and creating it into something a bit more coherent, so an actual propeller for a toy. You can see how I've created a primitive object and I'm positioning that blade on that primitive object ready for the Boolean operations in the future. You'll see me jump to another workbench in a moment. We'll actually clone that blade in the draft workbench and create a clone of that, rotate it and transform it into place. As you can see, I'm working in a non-restrictive manner. I'm not being forced down a workflow. I'm jumping out to different workbenches, using the features in those workbenches, bringing the results back into the part workbench, and using the features of the part workbench to add more detail to the model. So I'm flowing from one workbench to another. So I've used a clone from another workbench. That's the draft workbench. I'll then come out of that workbench, creating some features with the sketcher, and then extruding that feature over the part workbench, add some chamfers or some fillets just to create the rounded surface, and then finally boolean them all together. So when would I use the part design over the part? Well, considering the part design is a guided process, it's a well-defined process. When I have something like a technical drawing like here, and this is the prop of our previous project without the propeller wings attached to it, then I'll be looking at something like the part design, because I know from this picture here, this drawing, that I can create this shape just from one single revolve. I know I'm not going to go out to other workbenches because I don't need to. I can do what I need to do in the part design in a well-defined manner. That's not to say that you're limited to using the part design or creating stuff from technical drawings. You can use the part as well. It's a preference at the end of the day. I use both the workbenches, but I tend to stick to the part design when it's a well-defined process. And I don't need to use other workbenches when I'm modeling that part. So let's take this technical drawing and start from the beginning in the part design and show how I will create this. So we're looking at the technical drawing at the moment, and it's quite a simple object to create. We'll first start in the part design and we'll create a sketch along one of the planes, and we could be using simple geometry in there such as arcs, lines, polylines, etc. We basically work our way down through the technical drawing to create a profile of the object. And all we need to do is just do one single action upon here. So we're not going to be pad or pocketing. What we're going to do is create a revolve. You can see how this object is being built up quite quickly, using the constraints in there to fully constrain the model down. And we're creating one side of the profile and also the inner part that will be a void in there to allow for us to connect that to our toy. And then all we have to do is then select that sketch and create a revolve from there once all the constraints are in. So it's a very simple process, a single action, and it doesn't take long to create. And we have the finished product. So let's compare the two objects. We're in the part design at the moment. Got both the objects open, the part workbench and the part design. And in here we create a body. And we created a sketch because we knew exactly what this object will look like from a cross section. So we created the cross section in there and we used a revolve. We have a well-defined object and we was working quite contained with a well-defined process. Compare that to the part workbench. And I'm just going to hide the offsets and we'll come to those in a minute. We work quite organically. We may not have known the dimensions or had a rough guess of the dimensions. We might not have known the overall shape of the object. And we started from our base objects, working our way up and deciding what it should look like as we was building the object, allowing us to get to the final shape that we wanted. But what happens when it comes to these propeller wings that were created in a different workbench? How do we get these into the part design? Well, we could go for a loft in the part design to make it all one single object, or we could utilize the part. So this is where the part workbench allows you to take other features from other workbenches and include them into a part workbench workflow. We can rip the part design model apart and even rebuild it in the part workbench if we so desire. Let's see how we can get these into the part design object as one single body. So I'm going to come over to the part workbench object and I'm just going to control click both of these and hit Control C and hit OK. And we're going to paste them into here, into this workflow. I'm going to come down to the part workbench object and just close it so it's out of the way. So what we've got is basically a body, and also we've got the offset clone and the offset which originally come from the Suite 2 Rails from the Cursor Workbench. So these are not part of the part design flow, they're just in the same document. To get these booleaned into this object, the body, what we can do is come over to the part workbench, show this body, right click, transform it, and that's move it into position. We're just roughly moving this into position. Hit OK. And then we can use the part workbench to boolean this into the original object. So we can take all three objects and then union those shapes together. And we've created a fusion. So now we've combined the part design in with the part workbench. And that part design is quite safely bedded in here. We can then go off and 3D print this or export this out as STL model. One thing to remember with the part workbench, it is also a set of tools. So we have a number of tools in here. For instance, I can split this object apart by using any of the tools in the draft or the sketcher to make a cutting surface. So let's go for the sketcher. Look down on the top, make a new sketch, object XY, and we're looking at this, and I'm going to create a cutting surface, say a boolean B-spline, and we can come over to the part workbench, extrude that. So making sure the sketch is selected, extrude, we're extruding along the Z plane. I'm going to do it symmetrical and make sure we cover the object. So this can be used as a cutting plane now. So we can take our fusion, control click the extrude and split this object apart by going part, split, slice apart. Our object is now sliced into two. We look at the exploded slices, we've got a slice 0 and a slice 1, which I can right click and transform. So we can actually see inside that object and do other modeling actually inside these parts. So I hope that's giving you some idea of how the part design and part workbench actually differ. We're going to be going into how we use the part and part design together in other videos. It's down to your personal preference of how you want to use these. I just find that the part design is very good for, say, something that you've already got a technical drawing for, whereas the part workbench is when I want to go in there and just start modeling something and see it grow organically in front of me where I can just do adjustments. I may even take that part, look at the dimensions, create a technical drawing of it, and recreate it back in the part design, as I've done here. I hope that's given you some ideas of how these workbenches differ and also work together in that way. Thanks a lot for watching, and I'll see you again soon. If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a coffee site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel. Thanks a lot for watching and subscribing, and I'll see you again soon.